An explosion-proof exhaust fan is essential when working with flammable vapors like stains, varnishes, and paints in a confined basement space. Standard fans, such as a residential bathroom fan, are not suitable for this application because of the risk of ignition from sparks or electrical arcing within the fan's motor or components. Explosion-proof fans are specifically designed to prevent an internal explosion from propagating to the surrounding environment. These fans typically have several key features that contribute to their safety. Firstly, an enclosed motor assembly. The motor and other electrical components are housed in an airtight enclosure that prevents flammable vapors from entering and coming into contact with potential ignition sources. Secondly, spark-resistant construction. The fan blades and other moving parts are made of materials that minimize the risk of creating sparks due to friction or impact. Thirdly, temperature control. The fan may be equipped with temperature sensors that shut off the fan if the temperature rises to dangerous levels, preventing overheating and potential ignition of flammable vapors. When installing an explosion-proof fan, it's important to follow the manufacturer's instructions carefully. The ductwork should be made of non-combustible materials, such as metal or fiberglass, to prevent the spread of fire. The exhaust should be vented directly to the outside of the house, at least 3 feet above the ground, to ensure proper dispersal of fumes and minimize the risk of re-entry into the building. In addition to the explosion-proof fan, several additional safety measures should be considered to create a safe working environment. Firstly, proper ventilation. Ensure adequate ventilation in the basement to disperse fumes and prevent the buildup of flammable vapor concentrations. This can be achieved by opening windows or using additional ventilation systems in conjunction with the exhaust fan. Secondly, a fire extinguisher. Keep a fire extinguisher nearby in case of an emergency. Make sure the extinguisher is rated for Class B fires, which involve flammable liquids. Thirdly, a non-smoking area. Prohibit smoking in the basement to eliminate a potential ignition source. Fourthly, electrical grounding. Ensure all electrical equipment is properly grounded to prevent static electricity buildup, which can also be a source of ignition. Fifthly, local regulations. Check with local building codes for any specific requirements regarding exhaust fans in hazardous areas. These codes may specify additional safety measures or require permits for installation. To summarize, when dealing with flammable vapors in a confined space like a basement, it is crucial to use an explosion-proof exhaust fan and implement additional safety measures to minimize the risk of fire or explosion. Using standard fans in this situation is dangerous and should be avoided. Proper installation, ventilation, and adherence to safety precautions are essential for creating a safe working environment. Furthermore, selecting the correct explosion-proof fan involves understanding hazardous location classifications. The National Electrical Code (NEC) classifies hazardous locations based on the type of hazardous material present and the likelihood of its presence. These classifications are divided into classes, divisions, and groups. Class I locations are those where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class Roman II locations are those where combustible dust is or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class Roman III locations are those where easily ignitable fibers or flyings are present but not likely to be suspended in the air in quantities sufficient to produce explosive or ignitable mixtures. Within each class, divisions indicate the probability of the hazardous material being present. Division 1 locations are those where the hazardous material is present under normal operating conditions, frequently present because of repair or maintenance operations or leakage, or might be present because of equipment breakdown or faulty operation. Division 2 locations are those where the hazardous material is not normally present but might be accidentally released. Groups categorize the specific hazardous materials. For example, in Class I locations, Group A includes acetylene, Group B includes hydrogen, Group C includes ethylene, and Group D includes propane. The selection of an explosion-proof fan must match the specific classification of the hazardous location. The fan's motor and other electrical components must be rated for the class, division, and group of the hazardous material present. For instance, if the basement is classified as a Class I, Division 1, Group D location due to the presence of propane vapors, the explosion-proof fan must be rated for Class I, Division 1, Group D. Explosion-proof fans are designed and tested to contain an internal explosion without allowing the flames or hot gases to escape and ignite the surrounding atmosphere. They achieve this through robust construction, tight seals, and flame-arresting features. The fan's enclosure is typically made of heavy-duty metal such as cast iron or steel, and is designed to withstand high pressures. The motor and other electrical components are sealed within the enclosure to prevent flammable vapors from entering and coming into contact with potential ignition sources. Flame arresters are used to cool the hot gases produced by an internal explosion below the ignition temperature of the surrounding atmosphere. These arresters typically consist of a matrix of closely spaced metal plates or screens that allow gases to pass through but prevent flames from propagating. The installation of explosion-proof equipment must comply with the NEC and other applicable standards. Wiring methods, conduit seals, and grounding requirements are critical to ensuring the safety of the installation. Explosion-proof conduit seals are used to prevent the passage of flammable vapors through the conduit system. These seals are typically installed at the point where the conduit enters the explosion-proof enclosure. Proper grounding is essential to prevent static electricity buildup, which can be a source of ignition. All explosion-proof equipment must be properly grounded to a common grounding electrode system. In addition to explosion-proof fans, intrinsically safe systems can be used in hazardous locations. Intrinsically safe systems are designed to limit the amount of energy available in the circuit to a level that is below the ignition energy of the hazardous material. These systems typically use barriers or isolators to limit the voltage and current in the circuit. Intrinsically safe systems are often used for instrumentation and control circuits in hazardous locations. When selecting an explosion-proof fan, consider the following factors. Firstly, the class, division, and group of the hazardous location. Secondly, the airflow requirements of the application. Thirdly, the static pressure requirements of the application. Fourthly, the motor horsepower and voltage requirements. Fifthly, the fan's construction materials and features. Sixthly, the manufacturer's certifications and approvals. It is important to consult with a qualified electrical engineer or industrial hygienist to determine the appropriate explosion-proof fan for the specific application. They can assess the hazardous location classification, airflow requirements, and other factors to ensure that the selected fan meets all applicable safety standards. Remember that explosion-proof equipment is not a substitute for proper ventilation and other safety measures. Adequate ventilation is essential to disperse fumes and prevent the buildup of flammable vapor concentrations. Other safety measures, such as fire extinguishers, non-smoking policies, and electrical grounding, should also be implemented to create a safe working environment. Always follow the manufacturer's instructions for installation, operation, and maintenance of explosion-proof equipment. Regular inspections and maintenance are essential to ensure that the equipment is functioning properly and that all safety features are in place. In conclusion, selecting and installing explosion-proof equipment in hazardous locations requires careful consideration of various factors, including the hazardous location classification, equipment ratings, wiring methods, and safety standards. Consulting with qualified professionals and following manufacturer's instructions are crucial to ensuring a safe and compliant installation. Remember that explosion-proof equipment is only one component of a comprehensive safety program that includes proper ventilation, fire prevention measures, and employee training.